Yes, a grounding conductor, identified by its green color, is required in the service lateral. This requirement stems from the National Electrical Code, specifically Section 250.118.3, which mandates that a grounding conductor shall be installed with the service entrance conductors in all services. Furthermore, Section 250.118.6 states that where the service entrance conductors are installed in a metal raceway, the raceway itself shall be used as the grounding conductor. The presence of a grounding conductor is crucial for safety within electrical systems. Its primary function is to establish a low-resistance pathway for fault currents to safely return to the grounding electrode system. This pathway is instrumental in safeguarding equipment, protecting personnel, and ensuring the overall safety of the building from potential harm. The grounding conductor allows for the rapid clearing of ground faults. Without it, fault currents could linger, leading to dangerous voltage potentials and increasing the risk of electrical shock or fire. While it's true that the grounded conductor, also known as the neutral, and the grounding conductor are effectively paralleled within the service lateral, it's imperative to understand that they serve distinct and non-interchangeable purposes. The neutral conductor's primary role is to carry the return current during normal operating conditions. In contrast, the grounding conductor's function is dedicated to providing a dedicated path for fault currents and lightning surges, ensuring that these potentially damaging currents are safely directed back to the source. Therefore, both conductors are indispensable for ensuring proper grounding and comprehensive fault protection within the electrical system. The NEC mandates the grounding conductor for a number of reasons. Firstly, it provides a low impedance path for fault current. This low impedance path facilitates the quick tripping of overcurrent protection devices, such as circuit breakers or fuses, in the event of a ground fault. Secondly, it limits the voltage rise on metal parts. By providing a path to ground, the grounding conductor helps to prevent dangerous voltage potentials from developing on metal enclosures, equipment frames, and other conductive surfaces. Thirdly, it reduces the risk of electric shock. By ensuring that fault currents are quickly cleared and that metal parts are properly grounded, the grounding conductor significantly reduces the risk of electric shock to individuals who may come into contact with electrical equipment. And fourthly, it protects equipment from damage. By providing a path for fault currents to flow safely to ground, the grounding conductor helps to prevent damage to electrical equipment and appliances. It is important to note that the size of the grounding conductor must be appropriate for the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the service entrance conductors. Installing an undersized grounding conductor can compromise its ability to effectively carry fault currents and may not provide adequate protection. Additionally, the grounding conductor must be properly connected to the grounding electrode system. This system typically consists of a ground rod, ground plate, or other approved grounding electrode that is buried in the earth. The connection between the grounding conductor and the grounding electrode system must be made with a listed connector and must be protected from corrosion. In summary, the grounding conductor is a critical component of a safe and reliable electrical system. It provides a low impedance path for fault currents, limits voltage rise on metal parts, reduces the risk of electric shock, and protects equipment from damage. The NEC mandates the use of a grounding conductor in service laterals to ensure that these safety benefits are realized. Although the neutral and grounding conductors are parallel, their functions are different. The neutral carries normal return current, while the grounding conductor provides a path for fault current. Therefore, both conductors are required for proper grounding and fault protection. The NEC reference 250.118 outlines approved grounding conductors and their installation requirements. When installing electrical services, always adhere to the NEC and local codes to ensure safety and compliance.